And the credit goes to Mr.
Good morning to all the participants and the speakers. It is great privilege that we are going to end this program with the 2 weeks faculty development program on emerging research and computer science in IT. Today we have great privilege to have Mr. Gaurav with us. He is a solution architect, part of research and innovation at Altron, working on AI and ML and future of technologies. He has 15 years of industry experience, has come and completed MTech in data analytics. I welcome you, sir, at Bharati Vidyapeeth Institute. Now, I request sir to take over the session and enlightening us upon the AI and the ML and its use cases across the industries. Sir, please.
Yeah, great. Thanks, Dr. Vishal. So, hi everyone. As Dr. Vishal already pointed out, I'm part of research and innovation team at Altron, and we basically look at various use cases, developing various use cases in applied AI, and this it spans across various domains in life sciences, automotive, and software. So, I'm going to start the session today. Okay. So I'm just going to start with the basics of what is artificial intelligence and machine learning. Uh, as we already know that we as a species are the most intelligent creatures. So AI is part of is part of the computer science branch, and as humans can listen, the part of the branch is speech recognition, which conforms in context to human beings. We as humans can also read and write and understand the text. The part of the AI branch which deals with that is NLP, which is also called as natural language processing. And collectively, both of these speech recognition and natural language processing fall under statistical learning. Both are based on statistics, and they fall under part of statistical learning. Also, we as humans can also look at images, understand, create a picture of it with our eyes, and the part of that branch which deals with that vision is called as is computer vision. uh, and then this part of it is under called symbolic learning. So symbolic learning is what was there earlier, wherein we used I think you are all of mostly most of us are PhDs here, and we know that uh, deduction using the logic, propositional logic, and all that is part of symbolic learning. Also, it's part of image processing using the symbolic learning for computer vision. The other part is we also as humans we can move around, we can use our hands, we can through our sensory through our eyes, through our hearing aid, we can sense, we can move around, we can touch, and that part of branch in AI is called as robotics. Now, the other part is the understanding of the patterns. We are also able to make out patterns. We are also able to make out groupings, distinguish between them. And that part of AI is called as pattern recognition, which co-joined with the term, it's called machine learning. And machine learning is the second branch of AI corresponding to symbolic learning, which is also a non-symbolic AI. A symbolic AI is the part wherein we already discussed robotics and computer vision. Non-symbolic is part of AI, which is machine learning. Now, as humans, we have our brains which are connected through neurons, and if we can replicate that somehow, that part of branch of artificial intelligence is called as artificial neural networks, which can give us cognitive ability to replicate which we can do as humans. And this particular branch of AI is called as deep learning. which is subset of machine learning. So machine learning holistically is made up of statistical learning and deep learning, which is a broader term. Now, if we discuss computer vision as part of symbolic learning, uh, computer vision is also part of deep learning recently through using the convolutional neural networks, which basically convolve over the images to extract out features and learn as to what the image presents. And the use case which is used for using the CNN is object recognition, recognizing the objects, which we also do as humans. The other part is we also have memories. We can learn things, we can remember things, and that particular branch of deep learning uh, is called as RNN, or recurrent neural networks, which also has more deeper insights which can be done using LSTMs. So in short, CNN and RNN are part of deep learning, which help us to visualize, use images as part of object recognition, and RNNs as part of learning time series data, similar to what we do as keeping memories and understanding and remembering things. Okay, so now the next part is the all of these techniques help us to ideally do two things. Either you do classification or prediction. Classification is wherein if we have a certain set of data sets with labeled as into two classes or more than two classes, and we create machine learning models, and then we use that model on a unlabeled or a new set of data. We can classify it based on the learning which has been done. Prediction is wherein we have a data set, we have learned on it, and we predict the values, new values, which which is similar to regression techniques. So if we give a set of values as a labeled data, and then we build a statistical model which can be a simple line or a little bit non-linear, and we can predict as to on the new set of data what value it will represent as a label. I'll go on to various use cases later on, but this basically gives the gist of what AI, artificial intelligence and machine learning look like in detail, and how all of these components are connected together. And the three different areas of machine learning are supervised, unsupervised, and reinforcement learning. Supervised, in wherein we know the labels, we know what a data represents. Unsupervised is distributing data into various groups, grouping it out, categorizing it, and reinforcement learning is majorly into gamings to learn through trial and error, and all of these are part of machine learning. Yeah. So before I move ahead, any queries or questions in this part? Okay. 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 I'll move on. So just to give an understanding of AI, ML, and DL, to be a little bit on the clearer side, artificial intelligence AI is a broader term. So it enables the machines to think. But how does it do it? It does it using different set of subsets, which are machine learning and deep learning. Deep learning being the subset of machine learning, and machine learning is uses the statistical tools to explore the data, understand the data. So the underlying core is the statistics in machine learning. And there are three approaches, as we already talked about in the earlier slide, which is supervised, unsupervised, and the reinforcement learning in part as part of machine learning. Deep learning deep learning maps to a domain which is more associated with cognitive abilities of human beings, and which is more powerful than the simple machine learning and the statistical techniques. Okay, so we as human beings, we have seen a lot of things that have been happening recently, and AI, in broader sense, it's being used around us every day. Every day we see something new on our mobile phones, smartphones, a new application on the websites, uh, and AI is being used around us a lot now. So if you look around yourself, in transportation and deliveries, Uber is using machine learning for the expected time of arrival of rides. Uber Eats is using it for predicting the meal delivery times. All of this is textual data, working on the textual data to analyze and predict as to how much time is going to take with various set of features which are being used as part of the textual data. Then there is, of course, Facebook's facial recognition. And this use case, which is there, it uses deep learning part of CNN, convolution neural networks, with labeled set of data to recognize the faces as when the pictures are presented to it. Then we have the classic, which we are almost everybody is aware of, which are recommendation engines, and these set of use cases use natural language processing and machine learning together to predict and recommend items which are based on the previous set of history or purchases which have been done. And this is something new which I found. A mobile check deposit. There is a company called as MeTech Systems, which has actually recorded around 3 billion deposits by various banks in US, and it uses the mobile camera to scan it and send it out. And and this is being used widely now, and uses the converting the handwriting via OCR. So all of these use cases are all of these four use cases are around various categories of data. So the first one is around textual data using core machine learning. The second was around deep learning using convolution neural networks. Third one is around the NLP, the natural language processing, and machine learning. And fourth is around images, and of course reading it through OCRs. So these were all use cases which are around us. So what I'm going to do is I'm going to jump onto industry use cases, which certainly there are some use cases which we already are working on as part of our organization. Life sciences is one of the important domains which we as company are working on, and there are different sort of use cases and in life sciences which are precision medicine. So consider a case if a person has if a person needs to take some medicine every morning, and there are techniques, there are data which can be analyzed to see the optimal absorption of that medicine is going to be around what time, and depending on what sort of food items he needs to consume. All of this is going to be part of precision medicine, which is a very important and upcoming use case in life sciences. Then there is a very generic use case, which is patient data analytics, to understand the data which is generated by a patient with the use of sensors, etc. Then there are early diagnosis and medical image insight and drug discovery. So, as part of the uh, today's scenario, we know that we are going through a pandemic, and there is definitely a need for maybe an early diagnosis in COVID. And we, as part of Altron, we have done something around it, and I'll showcase that to you as well. And then there is drug discovery, I think, which is already going on in parallel, and the IT companies are helping out a lot for trying to find drugs which can be helpful in such a scenario, in such a pandemic, quickly, and that couldn't have been possible then without artificial intelligence. Then there is also automotive, wherein the use cases are auto insurance based on the driving data of users, collecting of the data through ports available in the car, sending it out, storing it on the cloud, and then analyzing it to have a precise uh, uh, insurance value. Or the other set of use cases are in ADAS, uh, uh, ad- ad- uh, which is basically assistive systems, driver assistive systems. Uh, Driver assistive systems can be like reverse parking assistance, wherein you have a ultrasonic camera fitted on the car, and it basically detects and assists the driver to take a corrective action, which is driver experience in automotive. Again, these are all dependent on textual data and image data, camera data converted into image data. And then there is autonomous driving, which certainly uses different set of sensors fitted on the car, which are the video cameras, the lidars, which are fitted on top, which gives a 360 view of the surroundings and the environment, to create the sensory output. All of these modalities collectively produce a large amount of data, which then can be used for uh, building autonomous self-driving cars, which is already been taking place in case of Waymo, Tesla, and which we are already aware of. Then we have Industry 4.0. So I think these all of these use cases are pretty self-explanatory in nature, where we have the predictive maintenance. So based on the previous set of data, we analyze and see which machinery or which area in the supply chain, which area in the management can probably fail, and then a maintenance cycle could be applied and corrective actions could be taken. Similarly, for robotics in manufacturing, quality control in industry, as well as in inventory management. So, uh, similar to it, telecom is an important area wherein network optimization, which was previously done through rules and logics, and more of hard settings, is now AI is capable of handling such optimization autonomously, and these systems can self heal. Basically, they would be able to heal themselves and find a different route to optimize the networks, do a capacity planning of the networks. And it's just not limited to the networks. It's more of also having use cases in terms of customer satisfaction, wherein ticket prioritizations can be done as to which ticket carries more weight and should be addressed first and autonomously. And there is a classic case which spans across various other domains, as which are fraud detection. Finally, for the last industry area, which is aviation, again, so predictive maintenance is common to the Industry 4.0 and aviation. Then again, customer service, as already pointed out in the previous one, through ticket prioritization and chatbots. And then there is fuel efficiency optimization through various data collected as to what route can be taken, as to how much fuel would be required for flying from one place to A to B, from a destination A to destination B. All of these things, AI is helping out in larger sense to optimize the systems to such an extent that the effort and the time both are saved. Yeah. So, uh, any questions from anyone so far, or shall I move ahead?
Mr. Gaurav, please move ahead. Hello,
Uh, Hello. Yes.
Mr. Gaurav, you may move ahead.
Okay.
I think participants are requested to keep writing questions in the chat window. And if
Sure.
you get a time, you can just have a glance on the chat window. If there are questions, you can pick up few of them which you want to answer and answer.
Sure. Sure.
Please move.
I don't have any yet, so I will move ahead.
Oh yes, please. Thank you.
Okay. So this was more about what is artificial intelligence and machine learning in a broader sense. Then what are the use cases which we've already seen, how it's affecting our daily lives, how it's actually improving our daily lives, and how it can improve our lives in cases wherein uh, uh, which are industry more of industry use cases. Now I will jump onto a little bit technicality of what is artificial intelligence and machine learning modeling. So what is an AI model? What is a machine learning model? So a machine learning models basically it uses data to find patterns, and it's basically just a file. So if you see a machine learning model which is based on numerical data, a file would be pretty small. It's because it has learned the linearity or a non-linear model. Based on it, it has created some variables and weights. Now, if you go on to maybe a more complex data set using deep learning, using CNN and RNN, and the data contains of millions of images, the model size was increased because there would be multiple set of trainable parameters and the weights which would be assigned, and this and the patterns which it has learned. So the major difference between symbolic AI and non-symbolic AI. Symbolic AI, which is also called as good old-fashioned AI, or in robotics, it's called as good old-fashioned robotics, Gopher. These are explainable because we have seen that we use facts and we use logic to deduce something. But a machine learning model are generally black boxes because uh, they don't explain the decision that they take. They don't explain it. So whatever it has learned, it is stored somewhere in that file, and they are black boxes which are hard to rely on. And the only way we can rely on are the matrices which are accuracy, or other matrices which are precision or recall or F1 score or AUC or ROC curves. But in all they are black boxes, machine learning models, deep learning models. So so what are the steps involved in creating this ML modeling? So I talked about the black boxes which are machine learning models. I am also going to talk about how do we actually understand these models in further slides. But before I go ahead, I would give a little bit of brief of what are the steps involved in creating this model. So the most primary and the important step is the data collection and the feature engineering part. And from my experience, from what I've seen with the hands-on which I did, I've seen the majority of the chunk of the time goes on to, I would say 60 to 70% of time, my time has went into the data collection, preparation, and the feature engineering part of it. To clean the data, to label the data, to do the importing of it, to do the formatting of it, and then to find which features are the important ones, which are correlated, which are not correlated, which I can drop, how I can make sure that I use the best features which I select. So all of this ha- this actually translates to a better model, because this is the phase wherein the most important part of AI and machine learning modeling is done. Then the modeling and evaluation, wherein when the data is created, when the data is formatted, which is ready for be feeding it to the machine learning algorithms, uh, this part comes in the modeling and evaluation part. So the 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 idea here is that we now we can quickly go on and use various libraries, scikit-learn, keras, tensorflow, because the algorithms are already there. So we just have to use them. We just have to feed the data and fine tune it. The challenging part, however, in the modeling is the uh, parameter tuning, the hyperparameter tuning, which would essentially would take time. But choosing the algorithms, because we don't have to write any algorithms from scratch. So we go ahead, we pick the models, we pick the algorithms, and we do the hyperparameter tuning. The last part is again then when the evaluation does, when you are satisfied that maybe out of 200 models which I created, I have found the one which is the best one based on my understanding of the metrics as to which metrics I would probably put more weight on. I would deploy it into the production. Okay, so now what I'm going to do is I'm going to take you. I wanted to keep this interactive, so I'm going to take you through a use case in healthcare, and based on this ML modeling, all the four steps, I'm going to map the cycle, the life cycle, cycle of AI ML modeling to these all of these four steps. And what better way to go than take something which is recently fairly new, and so what we did was we wanted to do something out and help out with the current situation, which is the COVID-19 pandemic. And this is one of the larger set of use cases which we are trying to build in COVID. And this particular use case is basically in deep learning convolution neural network based cuff detection and classification. And what we're trying to do is we're trying to first detect the cuff, so that we just filter out whether it's really a cuff or a different audio, and then do an classification of cuff into COVID or non-COVID. Now we have seen that even with developed countries, the pandemic has actually revealed how fragile the health system around the world is. Hello. Is there a question for me?
No, sir, it is fine.
Okay. So we've seen that how this pandemic has translated out, and it has shown that the health systems are so fragile around the world. And what we did was we knew that the COVID-19 cuff data is still not available, and we started doing it in April. And so that was definitely a challenge. What we could do essentially was only bucket the dry curves as COVID and others as non-COVID. And we also didn't have much expertise into the area. So we did a domain study. We did some material reading literature study on how the dry cuffs look like, how the different set of cuffs look like. And we try to build a classification model, initial classification model based on that. So again, so the data collection part, which is the first part of the AI ML lifecycle process. So what we did was we went on to the audio set, which is a Google audio set, which is a large scale data set of manually annotated audio events. And it had around ontology of 632 audio event classes and around 2084320 sound clips labeled for downloaded from YouTube's videos. And our interest was in cuff class, which was around 871 videos. And then we also looked at an ESC50 dataset, which is an environmental sound classification dataset. And we picked audio clips from there, which were just for cuff out of 2000 clips. Now, this was the data collection part which we did. The second process was to do a data preparation. And after doing the selection, so selection was based on which of those YouTube videos are actually good enough to be used as cuff audios. So first was just to filter them out and do a selection and discard the ones which are more of false cuff events or something which is made up and not occurring naturally. And this process actually consumed a lot of time to manually go through all of these YouTube videos and do a selection of those clips. Uh, After doing that, we did a download of those cuff audios, YouTube videos, converted them into the audio files, WAV files, and using certain libraries in Python. And then we also chose 40 cuff events from ESC50 dataset, which were the only ones present in that dataset. There were 40 in number. Now, after doing that, after filtering it, downloading it, we did a clipping of clipping of 5 seconds to all of these videos and audios which were collected, so that they are in sync, they are aligned. And now, after doing that, we remained with 501. We remained with 501 cuff samples. So I have a question here. Yeah, so is this use case in use? So yes, this use case is being translated and sent out as part of an mobile app which we are going to launch very soon. There are few more use cases which we are developing. How was the data of cuff selected format? So this was a WAV file, WAV file. Did you get cuff samples? This is from PL Lakshmi. Did you get cuff samples of positive cases? We have a few positive cases of cuff samples which mimic the dry cuff, and yes, we have certain which are part of this training process. The idea is to build this and send it out, and then use the feedback loop when we get more cases using the mobile app, and to retrain and improve the accuracy of the system. Okay. Uh, so cuff detector is a very simple use case. We chose 500 and cuff audios directly and equivalent non-cuff sounds. They were total 1042 records, and we used the CNN again to do a cuff detector, prepare a cuff detector model. So KPL Lakshmi is asking, so do you have the validated your algo output? Yeah, so I'm going to come on to that. There is one slide for that as well. So a cuff detector was fairly simple because CNN could easily translate, easily understand the differences between an audio which is cuff and an audio which is not cuff. But the challenge was to get good results on the cuff classification, because that carried audio for all cuffs, and we wanted to have a good marker, distinguished marker between both of them. Okay. So this was the so if I go back to the slide, data collection and preparation. So I am just through with this, and it took us a lot of time on that, and then feature engineering. So now we jumped on to doing the literature study of understanding how to actually label that, and we tried involving a doctor at that point as well, to validate our understanding as to whether we are doing it correctly or not. So each of these 500 cuff audios were analyzed. So we did a literature study and understood that these are various set of respiratory illnesses which are there. There is wet cough, which can either be a part of illness, or it can be probably just a flu or pneumonia. Then there is dry cough, which can be due to a throat infection or something that is irritating the throat and not really a lung disease. Then there is acid reflux cough, which is not really, which resolves on its own. Then there is RSV, respiratory syncytial virus, asthmatic cough, pertussis, croup, cystic fibrosis, and COPD. So while understanding these, we also tried hearing all of these, the sounds of all of these coughs.
So Pertussis group, they have a very distinct sound, a very different sound, which clearly demarcates that these are a different cuff and these are not dry cuff. Very different and distinct sound. So when we did all that, uh, we found that around 490 audio cuffs we were able to uh, label them clearly as to whether they were a croup or a pertussis cuff. Pertussis cuff is also called as whooping cuff, or whether they were wet or dry cuffs. And after doing that, we used and we said that the dry cuffs are COVID and the other ones are non-COVID. For starters, so we knew that this is the best we could do given the data set, and the feedback loop will come in and we would be able to improve the model further for a preliminary diagnosis of whether a person is carrying an infection of COVID or not. And then we jumped onto the actual modeling part in CNN. So we used two approaches for classification. One is converting the audio signal into MFCC, which is Mel spectrogram substitute coefficients. And the other one is converting it into Mel scan and Mel spectrogram images. So MFCC are basically features, numerical features extracted out from audio signal. And we used 40 MFCC features for training to be sent out to CNN architecture network. Usually the first 13 features from MFCC are the ones which carry the essential details, the complete envelope of the audio input. And the rest of them, the higher order features beyond 13, are the ones which carry the tone, pitch, etc. information of the audio signal. We use 40 and we also use spectrogram image and did a convolution on it to extract features and pass it on to the CNN classifier. We built two classifiers, but we observed that the one with MFCC performed better in terms of recall. I'm going to go on to that. So cuff detector was fairly simple and we achieved a good recall of 91% in case of classifying whether the sound is cuff or not non-cuff. And we relied on the recall for cuff because the class that we are interested in is the cuff, and we want to make sure that we have more accuracy and recall on the class which is the cuff. Then there is the second part, which is the cuff classification into COVID and non-COVID. We struggled quite a bit while applying variant set of different CNN architectures. We also went onto BGG16 and tried to replicate it to see whether we can get good results with MFCC as well as with spectrogram images as an input. The best we could do with the dataset, owing to the dataset which was small and manually hand labeled, we had 81% of recall. We achieved onto 81% recall, and the idea was to go ahead. Let's not wait for it, and let's go ahead and do a feedback loop later on with the actual data coming in, flowing in, and improve the model further. And there's also a white paper which we wrote, and it has been accepted to IEEE for the GUCON 2020, which is a conference which is going to come on in October. Yeah. So before I move ahead, if there are any questions on this, I can take now, or I can probably leave it for later.
Mr. Gaurav, you can move on.
Okay.
And Dr. Vishal will keep the track of the questions. The moment he feels there are many, he will request you to take up that, please.
Okay. So there's one question, one or two questions, then I can address now.
Yeah. In between, if you glance through and if you want to.
Sure. So one question from Lokendra is, what would be the co-founders in such case? For example, the quality of audio, sound, age, and gender. Yes. So we did take into account the audio, sound, the quality, and we tried to make sure that the quality of the audio sound, with the ones which are better with less noise or no noise, are the ones which are taken up as part of the learning. Now, age and gender, this is just one part of it. The curve classification, there are multiple set of other set of use cases which are coming up. A few of them are already completed. One is the decoloration of skin, trying to get get to classify whether a person might be carrying a COVID infection based on the skin coloration. And then there are again age, gender, and other set of features also used, including the ones which are temperature, data from oximeters, which is the oxygen saturation. All of these parameters also being used. All of these parameters are also being used to come to a bigger holistic picture as to how accurately we can classify a person as COVID or not, carrying a COVID infection or not. I think then there is another question: how is deep learning different from reinforcement learning? So reinforcement. Okay, so this is from Menesker. So yeah, I'll come on to that question. I think I'll address these questions first. So there is one question which is what confusion metric is telling. So the confusion metrics, Dr. Rachna, it's basically saying that uh, the accuracy is around 72%, which we got. The confusion metric is telling that the recall for COVID class. So the class which we are interested in, what we want to achieve is we want to make sure that we don't miss the patients which have COVID. So even if there are few more cases which are falling into the COVID bucket, which are not, it's still okay, because then they have to go through a testing, which is RT-PCR, which is the actual testing. But we don't want to lose the patients which are actually carrying COVID. So the focus on was to have a higher recall, higher percentage of people falling into the true positives. So even if there are more people who are not carrying the infection and still falling into the true positive bucket, which is still fine. So that is what the confusion metric is still. Do you have any classification data of COVID cough and non-COVID cough? Do you have any classification data? I think I didn't understand that question. KP Lakshmi. Can you please share the data set view? So Suruchi, what do you want to look at? I would probably want to know. Do you want to see the images as to how the data looks like? I can probably share it and quickly show it.
Gaurav sir, your screen is not visible.
Yeah, I'm sharing it.
Okay.
I'm sharing it. Okay, so yeah, Suruchi, this is what it looks like. I'm just showcasing this for the images which are the audios which are clipped and converted to spectrogram images through various Python libraries, through a Python library which is called a Librosa. So if that is something which you wanted to look at, I'm going to open the presentation again. Okay, and the next question is, do you have any classification data of COVID, any confusion metrics data of type of cuff identification? Yeah, so I'll share it out at the end. KPL Lakshmi. Yeah, so Suruchi, this is a question, is this a balanced or a non-balanced data set? So this is not really a non-balanced data set, because we had around, if I remember correctly, around 30 to 35 to 40% of values which were COVID. So we can't say that this is a non-balanced data set. So it's not like a data set in fraud detection wherein there would be around 5 or maybe 10, not more than 10% of the data set, which is 10% is still a large number. So not more than 3 to 4% or 5% of data set which is fraudulent. So this is not this is an average data set with uh, okay type in both categories. Is there a way to use CNN as optimization model? Please suggest. I actually didn't understand, Mushir. So I think if you say optimization model, what do you want to optimize? Or are you talking about pruning? Are you talking about optimizing the model to retrain and decrease the size of the model? Is that what you're talking about? Then what attributes, Sanjay says, good case study. Jyoti, thanks Sanjay. Jyoti, what attributes can be taken for classification other than dry cough? I think we thought through it a lot, and this is one of the classic attributes, which is dry cough, and we haven't heard still as to whether if there is any other different cough which is associated with COVID. So we went with it. Otherwise, we could have thought of maybe taking a different set of cough if wet cough was also one of the attributes. Yeah, so Akansha, I showed you the JPEG files. The audio has been converted into JPEG. Yeah, so I can show you that, but it's just a WAV file in a directory. If you want to see, these are just WAV files which are converted one-to-one mapping onto the spectrogram images to minimize cost function.
Yeah, can I
So
ask you a question? Just a question.
sure.
Yeah, so since you mentioned that this is based on the cuff classification, so clinically, if you see this phenomena, I think whatever app you're trying to develop, it can be useful at the later stages. But since we know due to the statistics that most of the cases are now asymptomatic, in those cases you may not have this sort of symptoms develop. So because so I don't know how much it will be useful in terms of point of care testing, because that is the main priority nowadays. That if you can develop something which can be useful in day-to-day routine, for example, from I think yesterday from Israeli group, they reported some breathing test, but it is basically a kind of physics or some biology mixture sort of. So you just put that in your mouth and take a breath, and then the breathing pattern will be different, and that can tell you whether you have some sort of infection.
Hmm.
So
I think
what do you think in terms of application of this app, especially for the pre-symptomatic or asymptomatic?
Yeah, so we started off in April when there weren't many asymptomatic cases, and we were already talking about symptoms. So now what we have done is we are trying to take in different set of parameters, not just this one. So the application that we are trying to build contains this as one of the use case as part of multiple set of use cases. And if you talk about asymptomatic, we are still trying to look at whether even if a person is asymptomatic, if at all there is a possibility that his oxygen saturation level might vary a little bit. So we are trying to find even smallest minuscule details which probably might go haywire and it all it depends on the data set that we are trying to collect on while we are launching this app. So when we start doing that, we probably might see patterns even for asymptomatic persons. And
You must be having Sorry, go ahead.
please tell me.
Yeah, so you must be having collaboration with some clinicians or some hospitals where you can get this type of data of breathing
Yeah,
habits
so
and talking.
not yet, but we are in talks with them. We are in talks with them to validate, basically. So validate our claims, validate our understanding. The application that we are trying to build will have a direct collaboration, and the app can be used by hospitals as well directly, and they would be able to see and probably give a feedback as to whether we are going in the correct direction or not. As for the asymptomatic, definitely we want to find patterns, and unless we have data, we probably would not be able to find that. We are trying to collect as much data as possible, everything from temperature, from images, from face images, facial images, from audio and cough, uh, from toes images. The COVID toe is one of the classic, one of the symptoms which is there, and then throat images. So we are trying to find as much. So there would be changes, even if person is asymptomatic. Something would definitely would change, because asymptomatic doesn't mean he's infected and he's feeling everything is fine. Uh, uh, his body is probably tackling it better than anybody and anyone else, but definitely few changes. Only probably a machine learning or a DL would be able to help us out and see. So this is one part of it, crop classification. This is the larger approaches. We take everything into account. I hope that answers your question.
Yeah, thank you.
Okay, so then there is another question from Nirmala, which says, "Did you apply any pre-processing techniques?" So, Nirmala, yes, we did work on trying to remove the noise in the audios if there were any noises. We looked at FFT, fast Fourier transformation, separating out signals and seeing whether we can uh, discard the noise and keep the audio, etc. So we did all that as well. So if there are no more questions, I can move on to another use case, which is a little bit different from what we have talked about so far. So there's something else which is of interest these days. So automotive, we're moving towards autonomous driving. Huge data, really huge data. So the problem that many customers have come onto us and they've talked about is uh, the storage is really a challenge. So the data is so huge. I think Waymo, they have a fleet of 200 in US somewhere, and the amount of data that is being generated per day is in tunes of 11 terabytes to 152 terabytes. And if we just multiply it directly with 200, the fleet of 200, it comes on to be petabytes, 2.2 petabytes to 30 petabytes per day, and that is humongous. Now, what do they do with the data? Why do they need the data? So the data that they are getting from is from various modalities, various sensors attached to the car for perceiving the environment, for creating a picture of the environment, and the modalities are ultrasonic cameras, radars, ECUs, sorry, not ECUs, IMUs, uh, and the front cameras, video cameras, etc. And all of these are generating good quality data which needs to be stored. But why does this data needs to be stored? The data needs to be stored because there has to be amount of validation and verification and validation that has to go using that data so that the self-driving cars are certified that these can run on roads with with an optimal level of security and safety. And uh, all of these vehicles trained, the software which is created has seen all the scenarios which can happen in autonomous driving. So this data makes sure that the testing, not just the real-time data, but the simulation data as well. So for autonomous driving cars testing, the simulation data is also created. The simulations are created based on the data. Augmentation is done, and the data is then uh, used for validation and verification. Now, why do we want to store that this huge amount of data? We actually don't. What we can do is, if we can somehow extract the data and move the common scenarios which have been there previously, collected by various other set of self-driving companies, we can do away with it. So the idea is to make sure that we filter records for purpose of having the diversity of data, so that various set of scenarios which are not occurring commonly in nature. So I'm not talking about daytime in a highway motorway, or a daytime on a city road, a normal scenario. I'm talking about scenarios where whether you are in tunnel, or whether you are driving on a rainy day. So all of these scenarios are diversity. So increase the diversity and minimize the data volume in terms of the common set of data, the scenarios, common scenarios. And then we want to make sure that we have those extraordinary scenarios which are there, and we record that and discard the ones which are common scenarios. So that's this just just summarizes one part of it. This is also in vehicle data reduction, so the data doesn't even need to be carried on to the storage, and the storage is not overwhelmed with the amount of data it needs to process every day. So a small POC is that we did. Okay, so what we did was we picked up various set of images, and we tried out two different set of things. One is we tried out an AI technique which is Bayesian belief network, a probabilistic graphical model with conditional dependencies, and this worked upon using the metadata of the data of the image as to uh, whether the what objects are there in that image, whether the weather is daytime, snowy, rainy, what is the scene, is it residential, city, street, etc. And all of these things we created a Bayesian belief network to see for a new image, to see whether it's an outlier or not. And then we also used autoencoders to train the autoencoder first on a diverse imagery data of vehicles, and then do a reconstruction of a new image which is coming in to see whether above a certain threshold the error is huge or less. So if the error exceeds a certain threshold, and the threshold is decided while we train the autoencoders, and autoencoders are part of deep learning, seen and on both sides. So extracting the features and rebuilding the features to reconstruct the image which it has seen. When we send out the new image to the autoencoder, it will reconstruct it with some error, and if the error exceeds a certain threshold, we say that it's an outlier. And this is something we're still working on, and would want to build an LSTM based autoencoder rather than a simple autoencoder, because a simple autoencoder would just reconstruct the image as it is, but doesn't keep the memory of what has happened previously. We would want to do something which keeps the memory what happened previously, a video camera, for instance. So if we have a sequence of 10 images from a video, and we build an autoencoder, it's going to predict another set of sequence of 10 images, and then we can see the error as to how erroneous the next set of sequences is, and then we can probably classify whether there is an outlier and the predictive sequence is different from what actually happened in that scenario. So this is another use case in automotive which we are currently working on, and it's an exciting use case. I have a question from Suruchi, sir. Where can we get the data set from? Suruchi, which data set? The cuff data set. It's available on audio set and ESC50. Now I'll just type it out. Audio set and ESC. You can just search it out. It's available. You can easily search it out. Yeah. So do we have any questions on this, or shall I move ahead? Okay. So I talked about black box. Machine learning models are generally black boxes. What does this mean? It doesn't explain why it predicted something, why it took some sort of a decision, and it doesn't tell us that. It just takes a decision. So we are just trusting it blindly on the basis of the accuracy of the model and other metrics such as precision, recall, F1 score, etc. And we choose a model and we deploy it. We were initially earlier not really bothered whether whatever the model is telling is correct or not, and it actually becomes a problem when the level of trust that we need is high in certain set of areas. So let me just pointer. Okay. According to Rachel Botsman, there's a book called "Who Can You Trust?" So, in human human sense, trust is the bridge between the known and the unknown, a confident relationship with the unknown. So, you're going from known to an unknown side, the uncertainty. But even though it's uncertain, the trust the part that connects us with the unknown. So if we trust something which takes time, always takes time to trust something or trust someone, going on to the unknown, this is a bridge that we want to make sure that's taken care of in machine learning and AI. So high accuracy of AI model by itself does not translate to trust. So there is another question. Yeah, so Nirmala, I'll answer that question at the end. I'll take that question at the end. So these are various set of AI applications. So if I just go down onto the product recommendation, the level of confidence required is low, and this is not a critical application. So even if the product recommendation is not as you expected and it's the AI is doing it wrong, we're still fine. The consequences are not high. We're not going to pay with dire consequences. It's just that customers might be annoyed, which is fine. But as we move on with the level of confidence required for trust, if it's high, something which is very likely in disease diagnosis, preventable death, that's the consequences. So if we can prevent death, that is something which we really need to. We have. Okay. So the consequences is pretty dire, and we want to make sure that this area, the disease diagnosis, the autonomous driving, the AI assistant for surgeons, here we are able to make sure that we are able to trust these systems. And trusting is a very important part. Now, trusting an AI model becomes a very important part. Since the symbolic AI is explainable, yes, but non-symbolic, the one which is machine learning, deep learning, is not. But how do we make it explainable? So at Altron, we have built a common framework, and our one of the sister company is Tesla, which is which is purely a AI consultant company, and we have come together onto building 5 pillars for building and deploying trusted artificial intelligence. What are those? So they are assured, explainable, human, legal, ethical, and performant. what is assured? So assurance is in trusted AI is that the data is free from any sort of bias, which is overlapping with legal and ethical. I'll come on to that. The data is complete in a sense. The data doesn't carry. Uh, it's basically doesn't have outliers. It doesn't. It's basically complete in a sense. It doesn't have empty values, etc. And it's free from bias. So bias can be of due to sex, gender, or religion, or it can be societal bias as well. So all of these factors play a role in assurance of the AI, and this part actually is a part wherein which can be addressed during the AI life cycle, which is more of data collection, cleanup, and pre-processing. Then the second part is explainability. So what is explainability? I just talked about explainability in the previous slide. Explainable. So when a model explains itself and says that these are the features I looked at and this is the weight I've assigned to each of the features. This is the features which say that why I took that decision. The explainability helps the person who is looking at the model to trust it and move forward with the decision. Next is human centric. So human is, although we are making it assured and explainable, everything is technical in a sense that a person who is an end user, probably a doctor, probably someone who is not well versed with technicality of all of these things. We want to make it human so that we translate it to something which is easily understood by them, the end users. The next pillar that we have is legal and ethical, which is more of again removing the bias around the data and bias if there's bias in the data. So I think if I remember correctly, Amazon was using created some AI tool to do hiring process and then it started getting biased toward female candidates. The reason being, men used to capture a lot of data in terms of highly different set of NLP or techniques, language techniques. The words were present in male resumes and were not present in female resumes, and it tended to get biased towards female. And the recruitment process did more of hiring of male than male candidates than female candidates, and it was dropped by Amazon. So that bias can have legal consequences. Another, I think, if I remember, another example of bias. I think US they built up an AI system to uh, recognize through facial recognition tool. They wanted to recognize. I think I don't remember correct. I'll come back onto it. There was another use case based on legality of it. The last one is performant. Performant is wherein to make sure that the model that which we are building is scalable. It's basically easily trainable again through feedback loops. Right? It improves itself when the new data comes back in. So there's a chance that if the new data comes back, if there is a new data which is getting generated and the model has to be retrained, possibility that the model would improve, or there is a possibility the model's performance might degrade. So all those things have to be taken care of. If there is a degradation in the model should not switch to using the new data unless there is a performance improvement. So what are the tools which can be used for making AI machine learning models explainable? One of the tools which we use have LIME, which is local interpretable model agnostic explanations. And what they do is they corroborate the decision made by the model through assigning weights to the features, which then can be understood by the human who is actually looking at the model which is created. Now, if you look here, this is the model which is created. These are the features: sneeze, yes; weight, uh, in some value; headache, no fatigue; age are the features. And these would this model would, depending on this set of data, would predict whether a person is having a flu or not. Lime, which is assesses the test input locally, which basically creates perturbed points around that test point and creates another model to explain the decision taken by the global model. So it creates a local model. The global model is the one which is trained, and it explains the decision taken by the global model using the test data by creating perturbed points around that data. And if you see here, the sneeze and headaches are the prime features for the decision, and the no fatigue is the evidence against it. Now, if something of that sort comes and says that this is what I've learned, and if a doctor looks at it and it says yes, I think it makes sense that sneezing and headache, if the sneezing and headache exist and person doesn't have any fatigue, yeah, maybe these are symptoms of flu, and the model has taken the reason correctly. It enables the practitioner to take decisions which are not black boxes anymore, and which enables and which empowers them doing that. There's one more tool which is called SHAP, SHAP. I haven't put it here, but that can also be used for bringing in explainability to machine learning models. Okay. Any questions around the trusted AI part, or shall I move ahead? Okay, I'll move ahead now. Okay, so machine learning tools. Just give me a minute, please. Just a minute. Yeah. Okay. Okay. So I have another question. I'll take that question. Yeah. So, Jyoti, I think that's a very good, excellent question. And there are so many things which are going on currently in the US as well. They have set up they have set up a legal framework around it. Actually, ethicality is a very broad topic. So, ethical in terms of self-driving. So, just think of a case. You as a person, if you are driving a car, and as a human, it all depends. It depends on your thought process. So if you have to, if there is no point, there is no way, and you are going to meet with an accident, and you have five people to save, and you have one person to save. You are going to go with 5 people, right? And I'm talking about geography, which is India, probably, and it might differ in a different geography. So there probably might differ in different geography. So ethicality, bringing in ethicality in robotics and artificial intelligence is a very vast topic, and still being researched as to how do we actually imbibe the legality and ethicality in self-driving cars. So it's an evolving topic. A lot many discussions are going on. There is I think one of the state in US have created a legal framework around it, but it's still evolving. And yes, we even I am not in a right position to probably say something that if we are through with this. So it's going to take time. It's really going to take time on that. So next is the tools, AI and machine learning tools. So from what it has been seen that TensorFlow, Keras are the most penetrated deep learning frameworks which are being used. And I haven't used it, but TensorFlow 2.0, I've heard it also enables machine learning algorithms to be built upon it as well. So I myself am thinking of switching on to TensorFlow for ML instead of scikit-learn, but I'll try it. And it seems TensorFlow integration with Keras in 2.0, and it's a very good framework to go ahead. So this is scoring which I obtained from towards data science. I'll move on to the next one. What do we use? Jupyter notebooks, ID, R, or something else? Uh, my preference always has been a Spider, uh, uh, creating the Python code directly from scratch into Spider. But I think a lot of people like Jupyter as well, and R tooling as well, R language as well. Jupyter, it seems, it's notebook creating notebooks is very easy for a lot of people, and I think is something which is apart from all of these gives more freedom for us to go ahead. I think this is something which is called as Google Colab. People would have heard it, Google Collaboratory. It uses your own Google Drive, create an account, and quickly go onto it. So there's no configuration if needed. I just started using it. It's very handy. Uh, uh, I can use GPU, TPU resources for free. Uh, uh, GPU, TPU resources for free on Google Collaboratory. I don't need to do any installations unless something which is not installed, but a lot of libraries are already installed on Google Colab, and it's based on Jupyter Notebook platform. So it's very similar to creating notebooks, and it's really I've liked it. So people want to go ahead and want to use it. I think this can be tried out. Google Colab. So there's question from Swaroop. Sir, can you please let me know the difference between TensorFlow and PyTorch as well as deep learning packages are concerned with GPU deployment? So what is it that you are asking? So can you explain the question? I actually didn't understand. So both are uh, both are deep learning packages, but what exactly is the question? Yes, I think. Yeah, sure. So
Yeah, hello sir. Good afternoon.
yeah,
Hello
good
sir.
afternoon. Good
Yes.
afternoon.
Yeah. Working on TensorFlow for some time. It is very good as far as the packages with respect to CNN and RNN are concerned. It has inbuilt packages which are built over Keras. But when we switch on to the hybrid system, something like adaptive neurofuzzy inference systems and related things, or any genetic algorithm or the nature inspired heuristic techniques, I'm unable to find any packages. In fact, it doesn't exist. But the same cannot be told about PyTorch as far as GPU is also concerned. So I just wanted you to put some light over those things.
Okay, so uh, I think you are correct on that. The heuristic techniques and genetic algorithms and the ANFIS. So you can go ahead and jump onto different framework altogether. If these TensorFlow and the Keras are purely have been focusing more on the CNN, RNN, LSTM side of things, and they have actually gone too far on that. but they still need to catch up on the other set of areas which probably different frameworks enable us. So you can use a combination of both of those.
Sir, for example, those packages are present in MATLAB. Can we export the data once we get the results from MATLAB or something like that to TensorFlow? Is there any packages like that?
I'll have to check. I'll have to check. You can drop a mail with the question and I will check and I can respond on.
Sure. Thank you, sir. Thank you.
Okay, so there are various set of resources which are available. So I can send it out to Vishal and he can also share it with you guys, which are online courses. I think the community who is there on the call today, on the session today, I think they would be well aware of all of multiple set of things which are available. But still, I'll send it out to Dr. Vishal and he can share it with the participants. Yeah. Thanks, Dr. Vishal. So I have almost I'm done with almost the content which I created for this session. If there are any questions that I can take up now, I'll be happy to take up. I think there was one question related to deep learning and reinforcement learning. Just to answer that, the deep learning it's basically not dynamic. So you have a training set. It's similar to machine learning. So you have a training set of CNN, RNN. You have a training set. You have labeled data, and then you create a model on it, and then you apply that model onto a new data set wherein you predict something. If need be, reinforcement is more of dynamic learning by basically a continuous feedback to make sure that the reward is maximized, and then the learning happens in that fashion. If that answers your question. Moraji has asked a question: data is augmented or not in COVID analysis? No, we didn't augment the data for the COVID analysis for now. See, the data augmentation would have worked in case of images which had clear features, like if you're going to classify a cat or dog, you want to maybe augment them, rotate, etc., all of those things. But in spectrogram, we didn't try it. We can try it, but the thought process was that the augmentation probably would not help much, so we didn't use it.
So which are the different tools which are using by industry for the purpose of machine learning?
Okay, so holistically speaking, you would probably want to take a look at AutoML, which is certainly an interesting area to look at. So you wouldn't need to be focusing on creating machine learning algorithms or pulling it out. It would automatically select. Then there is AutoKeras, which is something new, which we tried it out. It also does a certain level of hyperparameter tuning by itself. AutoKeras, AutoML, and then there are a few more tools. I don't remember right now, but I can send out the details to you as well. So we are actually looking at different set of tools so that we don't need to spend most of the time on boilerplating and use which is already existing, not writing everything from scratch, focusing more on the core part, which is the data cleaning up, rather than focusing on building algorithms.
So do you hire freshers for the machine learning as we take the campus interview? So do you take any particular students for machine learning or a general?
I'll have to check. I am not sure. I'm not sure, but I'll have to check. I can check and get back to you.
Okay. Thank you.
So I got a question from KP Lakshmi. Thank you for sharing the most open work. I'm still not clear how you got samples of all the cases. We didn't get positive cases, a lot of positive cases of samples. We did get some. We found it on YouTube. there are few cases which posted their cup samples here and there. So we got that's how we got the cup samples for positive cases. But they aren't much. It was more of adding them to the dataset and also doing a comparison as to uh, how the cuff sound looks like for COVID, and how can we make sure that the normal cuff sounds, which are dry cuff, are similar to those. So bucketizing the cuffs which are not COVID to COVID in case they are dry. This is the most difficult task to us to got in the approach points. Not yet. So we haven't made it public yet, Lakshmi. So I would do it in some time. I would also publish a GitHub link with the code and as well as the data set which I've used.
Sir, any suggestion would you like to give the faculty participants to make the preparation for the students for campus placement?
Yeah, I think so. The idea would be to understand the concept rather than jumping onto toolings which hide the complexity, and they create a wrapper around the core technology. So I would suggest go with uh, learning with the core, which is more of scikit-learn, TensorFlow, the basics, and the concept. Understanding the concepts, etc., would be better, because that helps you to create a solution to a problem rather than quickly just jumping onto tools and working out a solution. If you understand the concept, I think that makes your life fairly simple.
Okay. So as you completed MTech in our data analytics, so can you please suggest few books on the data analytics for the basic learning? What is analytics? What is data science? Any basic book which you would like
Uh,
to share?
Yeah, I'll share some name of the books. I don't remember all of them. So I think one of the books was on statistics. I'll still have to check who it was written by. So hypothesis testing, all of these, the Gaussian processes, the normal distributions, etc. I think that is very handy. It gives you a very good grasp of what statistics is, because it forms the basic of data science. Statistics is something which you should look at, and then you should jump on to uh, the machine learning part of things. The statistics is something which is important part of it. I'll send you the details.
Yes, yes.
I'll send it out to Dr. Vishal.
Yeah, thank you. Thank you. Any other question? Any participant would like to discuss something? There is a question, sir.
Yeah. So as we have progressed from AI to ML and now to deep learning, what do you think of the next learning technology? Uh, if you look at it, I think there are so many things to learn. So new things are getting built along the way. So I didn't know about LSTM based autoencoders. So I came to know about it. So I've been working on it now. Then there is GAN, generative adversarial networks. So these all of those things can be you can take a look at. I think being an IEEE session, you can go to on Springer, IEEE, and you can download papers, various research papers, and uh, download the latest ones, 2019, 2018. You can see so many new technologies, so many new things which have come up. GAN is something which I am quite interested in, which generative adversarial networks, which can be used to build compose music, so which can generate images, which can generate faces, new faces as well. So it's an important, it's a very exciting area which you can look at. GAN, generative adversarial network.
Yeah, that's fine, sir. Any other would like to discuss something? So that so there is after industry 4.0, now we have a industry 5.0. So can you differentiate what are the upcoming areas in the industry 5.0?
So I think industry 5.0 is more of autonomy and uh, so in terms of safety, quality, and all of these things, The 4.0 is on the edge. So 5.0 is going towards autonomous thing. So autonomy is the part which industry 5.0 is going to look at.
There is one question that can we apply our analytics on the deep learning? I think yes, you can apply. What do you feel?
Yeah, that is correct.
So I don't think so that there is any question pending, sir. Thank you so much for accepting our request for being a part of this 2 weeks faculty development program, and it was a wonderful session. I just checked the availability of our director, sir, Hude, sir. Then we will wind up this session.
Sure, Dr. Vishal.
Yes, sir.
And it's my pleasure for you
Sir
guys
is
to
coming.
invite me.
Sir is coming.
So, Mr. Gaurav,
Hello, Mr. Director. Yeah, hi, how are you?
thank you so much for a very useful lecture. Lectures from academician and lectures from practicing experts from industry are different. And that you proved it while giving it. And with respect to the exploring AI for improving the day-to-day life and overall quality of mankind on earth is yet to be explored further. I remember around 30 years ago, when we were a student and were asked to study AI, students, all of us used to hate that what the subject we are studying. But now, not only the computer scientists, not only the engineering, rather even the social science people, the humanities people are talking of AI. That is a kind of penetration, that is a kind of percolation of the subject, that is the kind of the reach and richness of the subject which has gone deeper into the day-to-day learning system. And we are sure this subject of AI will be having much more significance in days to come, not only in industry 3.0, 4.0, also in 5.0, and next one decade is of artificial intelligence. Thank you so much, Mr. Gaurav, for having delivered it excellently and having joined Bharati Vidyapit MVP. Keep in touch and keep joining Bharati Vidyapit programs. Thank you so much.
Thanks, Director Sir. It's really a pleasure for me to come here. Actually, someone else was supposed to come, but I think I'm quite happy to facilitate this session. And looking forward to doing it again if required.
And our team has been proactively preparing certificates, so the certificate is ready and it is for you.
Thanks a lot, sir. Thanks a lot.
On behalf of Bharati Vidyapit and on behalf of all the participants, please accept this token of certificate just for appreciation of this session, sir. Thank you so much.
Thanks a lot. Thanks a lot, everyone. So I'm hoping I would take another session with you guys.
Yes, sir,
Hopefully,
definitely.
hopefully face to face after this is all over.
Yeah, after lockdown period, we will schedule one session with the students and faculty members also in near
Definitely.
future, very soon. Thank you so much,
Thanks
sir.
a lot.
Thank you.
Thanks, everyone. Thanks, guys.
I request to all the